Have you ever wondered if the way we train engineers is, well, fundamentally outdated? That's the core question behind a really fascinating proposal called the EcoSolver Model. It's a pretty radical rethinking of education, and it's all designed to create a new generation of problem solvers for our planet's biggest environmental challenges. So let's dive in and see what that looks like. All right, so to really get what the EcoSolver model is trying to do, we first have to talk about the problem it's trying to fix. And it really all boils down to this huge disconnect between how we learn in the classroom and what's needed in the real world.
And this question right here, this really hits the nail on the head. For decades, universities have trained engineers in these separate, isolated silos. You've got your chemical engineers over here, your biochemical experts over there, and your energy specialists in a totally different department. But the real world, it just doesn't work like that. The second they graduate, they're thrown into these massive projects that demand they all work together seamlessly.
Look, this old model might have worked just fine for the 20th century. That was a time with way less automation and, let's be honest, not a lot of environmental rules. But today's world is a completely different ballgame. We're now dealing with incredibly complex automated systems and, of course, massive environmental pressures. This new reality demands specialists who can think and act like a single, cohesive team. The old educational pyramid just wasn't built for that.
I mean, just take a modern wastewater treatment plant as an example. It's not just one simple thing. It's this incredibly complex ecosystem where you need biotechnologists, thermal engineers, and power generation experts all on the same page working in perfect sync. This is exactly where those old academic silos start to completely fall apart. So, if that's the problem, what's the solution? Well, this is where the EcoSolver model comes in, offering a totally unified approach to engineering education. At its heart, EcoSolver is basically an educational framework built to mimic reality. It's a unified, interdisciplinary program that's designed to train engineers to see the whole system, not just their one little piece of the puzzle.
So how does it actually work? Well, instead of just textbooks, it centers the entire curriculum around complex, real-world systems, like waste incinerators and wastewater treatment plants. These facilities are the perfect learning labs because, by their very nature, they force chemistry, biology, and energy science to work together. The whole goal is to create professionals who are ready for anything, from running day-to-day operations to doing groundbreaking research. Okay, so let's take a look at this in action. What does this integrated approach actually look like when you apply it to real-world technology?
Let's take a waste-to-energy plant. On one side, you've got the combustion process making electricity. That's your classic power engineering. But at the exact same time, you have this super complex system purifying the flue gas, which is 100% chemical engineering. In the EcoSolver model, a student wouldn't see these as two separate subjects. They learn from the start that these systems are completely dependent on each other.
And it's the exact same story at an advanced wastewater plant like this one. This thing isn't just treating waste, it's an energy-positive system. That means it actually creates more energy than it uses, turning waste into a resource. It's just a beautiful example of the synergy between biotechnology, all the biological processes cleaning the water, and energy engineering, which is capturing and using the biogas that's produced. And all of this incredible tech operates under a single guiding philosophy, the waste hierarchy. The goal here isn't just to get rid of waste better. It's about a complete shift in how we think, where preventing waste in the first place is the #1 priority, followed by reuse and recycling. Getting rid of it, disposal, is the absolute last resort. This framework is the why behind all the engineering how. Now, as you can imagine, teaching this way requires more than just changing a few things in the syllabus. It really demands a fundamental shift in how we approach learning itself. This right here gets to the philosophical core of this new teaching method. The whole idea is to move away from just memorizing a bunch of facts out of a textbook. Instead, the EcoSolver model pushes students to actually get involved in the research process itself. It's about learning how we know what we know, not just what we know. It's a huge shift from being a passive listener to becoming an active investigator.
And to make this happen, the authors are proposing a pretty bold restructuring of higher education. Essentially, they want to push research skills down to the earlier stages. So you'd start introducing master's-level research concepts to bachelor students. Then you'd use the master's program to really sharpen those skills we usually associate with PhDs. And the result? It's really exciting. The PhD program transforms into a pure incubator for discovery, where students are already expert researchers, ready to go out and create brand new knowledge.
Finally, this whole model is built on a really inspiring vision for what science can be in our society.
This quote, this just captures the essence of a concept they call total science.
The big idea is that curiosity and research aren't just for professional scientists in some high-tech lab. No, they're fundamental human drives that we should be nurturing from the time we're kids and all through our lives.
And this is the ultimate endgame, to break science out of the ivory tower and make it a meaningful hobby for everyone. You know, just like playing an instrument or painting. Can you imagine a world where people from all walks of life are taking part in scientific research projects, not for a grade or a paycheck, but just for the pure joy of discovery?
So we're left with this really powerful question. At the end of the day, the EcoSolver model isn't just about training better engineers. It's a blueprint for a future where our own curiosity is our guide, and a scientific mindset is something that's accessible to all of us. You gotta wonder, what would our world look like if that vision actually became a reality?